said the last thing we talked about was stratified, sorry. And there's the recording and e-text 5A. I'm already there. And dadgummit. Sorry. There we go. I don't know what page stratified is on, so I'll just keep looking unless somebody's got a book in front of them. Okay, here we go. Stratified would be grouping. And let's see what's on the next page. And there are some examples of actual, the actual sampling. So if you want to write those down, those are good examples. Let me make it a little bit bigger for you. Some of the computer programs that are used picks every 5th person or every 10th person in the phone book. There is convenience sample. Do you support the death penalty? Well, you could actually say that that would be inaccurate because he's walking his dog, so he cares about the health of his dog. So chances are that he doesn't believe in the death penalty. You could say that. I mean, I'm not saying that it's true. I'm saying that you could say that this, remember what I said about convenience sample. Convenience sample is the least accurate. It's the most convenient, but it's the least accurate. So make sure you write that down because it can be, like I said, the best for you, but it's not that accurate. All right, so just please write that down. And I don't really care about stratified, but stratified is basically grouping. Somebody tell me what they think that word means right there.
Bias?
Anybody?
Like that word?
Bias. I got it highlighted right there. Bias. Anybody?
Basically to be heavily for something or against something.
Yes, exactly. Is that a word that is being used a lot today?
Probably.
Yes, it's being used a lot. I'm not going to get into the details. I'm going to let you do that because that's what, part of learning is, to find out why that word is being discussed. But this word right here, and you can write this down, that word right there can kill you if you are a statistician or you are in quality assurance or probability and statistics. This right here can bring you down more than anything. All right. Now, I have used in the past 2 examples of somebody that's non-biased. Can anybody think of any profession that is non-biased?
A doctor?
A judge?
There you go. I was thinking of a judge, but a doctor has to give you good news and bad news, doesn't he or she? And I remember my dad died in 2014, and his best friend was his doctor. They had cows together. They did things together. And I remember, I'll never forget him telling us that my father was dying, because my father died like within a week of when he told us, because He had ill health. And he said, this is the hardest thing for me to do. And, you know, you got to think about it. I never thought about that, Mr. Stubenhofer. I've never thought about a doctor being neutral. But, yes, he had to sit there and tell us, and we've been knowing each other for, oh, my gosh, more than 25 years. And he's been knowing my father longer than that. And for him to have to tell us that my father was dying, yeah, that's a good observation, Mr. Stubenhofer. But Mr. Chadman, you are correct. That's one that I use as a judge. Also, a referee. There's an episode of Andy Griffith. It's a color episode, and I don't watch the color episodes, but he's asked. There's one black and white episode where he's asked to be a judge for a beauty contest. And then there's one episode where he's asked to be an umpire for the baseball game. And in both cases, he was treated terribly because he was a judge. And I can't imagine being a judge, but I can get a taste of it. I sit on what we call a land use board. And I'm not telling you this story because it's me. I'm telling you this for a reason. On the land use board, we decide whether people get to do things with their property that Anderson County says you can't do, all right, or can do, or whatever. And when something is kind of in the gray area, they come to us and we vote it up or down. And there was this one guy or one case where, and there's 7 people that sit on this board, and I'm the chairman, so I have to do the talking. And he wanted to put a mobile home on a piece of property that was, I'm just going to say, less than a half an acre. And less than a half an acre is not good because DHEC requires that you have at least a half an acre before you put a septic tank on it. Does everybody understand that? You got to have at least a half an acre before you put a septic tank on it.
Yes, sir.
And the question was not whether he could put a mobile home there. The question is whether he could put anything there and have a septic tank. And we were discussing it, and we let the people that move. There was a bunch of people there that was there to speak against this guy doing something with this little piece of property. It was like at the fork of the road. It was like a V-shaped piece of property in the fork of a road, between 2 roads, the split. And they were all giving him all down the country. He's going to put in a mobile home. He's going to put in a trailer. He's going to put in this. He's going, you know. And after everybody talked, I said, okay, I'm going to close the public hearing and I'm going to speak. And the board members can speak. And I said, whether he puts in a mobile home or a strip club, that's not for us to decide. I said, I lived 10 years in a mobile home before I built my house. I said, there's nothing wrong with a mobile home. I said, that's not for us to decide. Every one of you have said he's going to put in a mobile home, or, you know, y'all haven't addressed the septic tank issue. And we voted that he could not do what he wanted to do. And I said, after we made our decision, I said, you could put a house there or you could put a mobile home there. That's not the question. The question is whether it's legal by the septic tank. Now, a lot of people, why am I telling you this? When you are given a neutral position, you cannot be slanted either way. I think a law enforcement officer is a good example of non-bias. Now, you've got your Barney Fifes in every group. You got one out of every group that's going to be stupid. So I'm not going to talk about those. I'm talking about the good people. They are not. They have to deal with people every day, and they try. I would assume they try to be non-biased. But in a statistical probability issue, or if you've got a job where you work with probability and statistics, you cannot be biased, because if you ever are found to be biased, that's going to be probably it for you. Okay? Yes, bias is going to one side or the other. Now, I've spent probably 5 minutes talking about this one word. It's very important. It's very, very, very important, no matter what profession you go into, because you cannot lean one side or the other and, be in a neutral type. You can't do it. And that was a good example, doctor. That was a good example. I appreciate that. So you can't be biased.
Thank you.
A statistical study, when it's designed to conduct, tends to favor certain results. There is a quote by Mark Twain. I want you to write it down. Mark Twain. I know the quote. I'm just going to show you the quote so you can write it down. And let me just, it's easier images. Well, there we go. There they are. There are lies, there are damn lies, and there's statistics. Now, I want you to write that down because I think that's a very important. I go by a few quotes. One quote, nothing in life is free. And the other quote is, we are a product of our own decisions, our choices. And one of these, this quote, there are lies, damn lies, and statistics. That basically means that there are people in statistics that use statistics to get their point across. Okay, and they are basically liars. And lying is a big word, and some politically correct people don't want to use that word, but it is a word, and it is what people do. And basically, if you are a statistician, you have to go out of your way to show that you're not biased. And
So what is,
say
what
again?
is the damned lies part?
In other words, there are lies, there are worse lies, and then there's statistics. Damn lies mean you're lying even on top of a lie. I guess a worse lie. You see what I'm saying?
Yeah.
In other words, there are people that just lie. Then there are people that put lies on top of lies and statistics. So you got to, in other words, you got to be very educated in statistics to be able to catch a lie in statistics. And that's part of one of my quotes that I live by, and that is, knowledge is power. And some people want to keep people ignorant, because if you can keep people ignorant, what can you do to them? Anybody want to fill that in?
Manipulate.
Exactly, Mr. Chadman. Exactly. And I'm talking about in a work setting or in a national setting or in a local setting. If you keep people stupid, they're easier to control. So with that being said, when you go into a statistical presentation, you got to know your stuff to be able to catch somebody being biased. And if you know your stuff, if you educate yourself, then you know if somebody's being biased during a presentation. Okay? And think about it. Explain why concerns about potential bias lead television networks to use Nielsen, an independent company, to measure ratings rather than doing it themselves. Well, that's kind of self-explanatory. I think it's ironic that they use an example, of course, with Nielsen, but they're using them with what? Television networks on bias. I think that's kind of ironic, but I'm not going to leave it there. All right, let's move on. Did we talk about observational study versus experiment? I think we did we not? Okay,
I don't
nobody.
have my notes, but we did a 120.
Okay, thank you, Miss Gill. You have to watch it because I talk about this stuff in both classes, so I have to ask you if I covered it because sometimes I forget. All right, here we go. An observational study. I'm trying to get my, there we go. An observational study is a study where you basically just watch somebody or watch something. Okay, cars going across the intersection, counting cars. There are actually jobs in the highway department where you count cars. Nowadays, they put a rubber hose across the road. Have you ever seen a rubber hose across the road? That is a car counter. And what it does, it fills up with air, and whenever you run over it, it trips a counter. And if that road is predominantly, if it's a county road or a state secondary road, then it's divided by 2 because most of the axles that go over is divided by 2 because you have 2 axles. So that, and if it was a highway like I-85, then they would take an average of 18 wheels, 6 wheels, 4 wheels, 2 wheels, and they'd get an average and they would divide it by that number because of, you know, the, to get the count of how many people are crossing or using that road. How many of you have seen a rubber hose across the road, a black rubber hose across the road? Anybody?
I think I have.
Yes,
Okay,
sir.
that is a car counter. That, that's the car counter. It replaced people sitting on the side of the road or in the highway department truck or vehicle counting cars. And they usually count cars at intersections because it's easier, because they have to stop. So you actually, that is an observational study, a car count. Okay, the old car count, not the rubber hose, but the just watching somebody or watching an event is called an observational study. Excuse me. Sleep apnea. Sleep apnea patients, and before you know you've been diagnosed with sleep apnea, they actually, you know, or they used to, they get you to come in and sleep a couple of nights while they video you and monitor your breath and your heart rate. And that is an observational study. What if I was to slip in the room while you were sleeping in a sleep apnea study, and I was the doctor in charge, and every time you moved, I would shock you with a cattle prod? Would that be an observational study or an experiment?
An experiment.
It's an experiment because I have interacted or interjected. You can also put interjected. You either interact or you interject yourself into the observational study in some form. Now that could be changing medication into sugar pills, or it could be putting a piece of cheese in the maze of the mouse with the mouse in it. Okay, interjecting and interacting could be in a non-physical form with something else. You don't have to interject, but you may interject something into it. All right. That's the difference between an observational study and an experiment. This is a standardized test question, so make sure you write these down. Also, when you're talking about an experiment, what are the outcomes and what causes the outcomes? And that's these two guys, cause and effect. How many of you have ever seen the Matrix, second Matrix movie?
I have.
Okay, restaurant scene where Morpheus and Trinity and what's his name Neo walk into the French restaurant, and the guy said, "I want to see," and Morpheus says, "We want the key maker." And the guy at restaurant, he's talking in a French accent, and he goes, "You're here. I know why you're here. Cause and effect. I drink too much wine. I have to pee." All right, cause and effect, and that's what the experiment and sometimes the observation is all about. Cause and effect. The cause is usually the explanatory variable. The cause. What do you mean? Well, in order to make ice, an ice machine has to have what? Water. And some folks would say electricity, but the main ingredient is water. You can put electricity on an ice machine all day long, and it'll burn up the motor and the compressor because there's no water coming into it. So electricity is really secondary. You got to have water to make what? Ice. You got to spend money to what? Make money. So what is the input? The input is usually the independent variable. In statistics, it's called the explanatory variable. That's your input, which could be in mathematics, your domain. And the cause produces the effect. Output is called the range. And in statistics, it's called the response variable. And it is usually the dependent variable. So make sure you understand that with an observational study and experiment, they both have cause and effect. Let's say you've got an observational study on a road that's within a half mile of Bosch or within a half mile of Michelin. Well, you know that the car count is very high at 7 o'clock, at 3 o'clock, and at 11 o'clock. Well, what would that cause be for that traffic to be high? Well, it's changing shifts. So that's why the change in shifts causes the high traffic. All right. Whether it's observational or whether it's experimental, you've got to understand mathematically and statistically what these guys are called. And all of these math terms down here and right here in statistics is called the explanatory. I hope I say that right. I don't know. Explanatory variable, and the output is called the response variable. Do you have to hold your pinky up when you're saying that? Yes. This is a fancy word that means all of this that you learned in algebra. Fancy word, algebra terms. And you will find out that the more you go up in mathematics, the more you put on airs by holding your pinky up and saying big words that mean the same thing that you learned back in 6th, 7th, 8th grade. Now I'm going to go ahead and talk about confounding. Confounding means that you could have correlation, but that doesn't mean that you basically have correlation or causality. Correlation, let's write that down. You may need that one day. Correlation does not equal causality. But causality equals correlation. Correlation is a pattern. This is correlation, meaning being able to take all these dots and draw a line, which is called the best fit line, and have a bunch of dots over here and draw a line that fits those dots there. Let's say that I do an inventory of 2 months of the running of Nicolas Cage movie Con Air at the movie theater. And I find this correlation right here. Okay, this is ticket sales, because you can't make money unless you sell a ticket. And this is money. All right? And here, this is days or time, and this is number of deaths times drunk driver or whatever, or suicide rate. I'm sorry. This is number of deaths, and this is time in the last 2 months. And I go to the hospital to get this information, and I work at Amstar 14. Well, I have a correlation here. That's a correlation. R is equal to 0.82. And I've got a correlation here that R is equal to 0.79. So can I mathematically say that if you watch a Nicolas Cage film, you're going to commit suicide? Yes or no?
Probably not.
Exactly. All right. This is where something called, some people don't have it, but what? Common sense dictates these two have nothing to do with each other. Nothing to do with each other. But correlation does not always equal causality. All right. Now, I put that R factor. I don't think we're going to be going into the R factor. I don't. In fact, they just took it out of Math 120 also because of the shortened semester. So, but the R factor is basically the slope of this line. It relates to the slope. So it's kind of like the slope. It's from negative, correlation coefficient is R. It goes from -1 to +1. And it goes, you know, if you have a strong negative correlation anyway, this 0.82 and this 0.79 is close, but correlation does not mean causality. A Nicolas Cage film, as terrible as they usually are, does not mean that you're going to commit suicide because you watched a Nicolas Cage film. Now, there are some films right now that they're putting out in Hollywood that might cause you to commit suicide because they're terrible. I watched Wonder Woman 84, and even though Wonder Woman is a beautiful woman, that actress is a beautiful woman, that movie was about the worst movie I think I've ever seen. Anybody ever seen that movie?
No, my mom is excited for it.
Well, tell me what she thinks of it, because I thought it was terrible. The first
She's
movie I thought was
fairly
good.
cool with it.
The first Wonder Woman movie where she, you know, fought all the Germans and whatever, I thought that movie was good. This movie was terrible. But
The new one?
anybody else see it?
Yeah, it was too slow.
I thought it was just too slow, and it was cheesy.
Nothing happened until the end, I guess.
Yeah, but the villains were stupid. Didn't you think the villains were stupid?
Very much so.
Okay. Well, I thought the villains were just, in the first movie, I could understand the villain for the German Reich, you know, being a god of war. I could understand that. But this woman who has a low self-esteem that touches a rock and she turns into a cat, I mean, it just didn't, that movie didn't play well with me. And I love movies. I love them. I watch them all the time. I watch more movies than I do sports. And I really thought it was a terrible movie. All right, so what about the correlation of drowning deaths? Let's say that's a correlation of 0.86, and Rocky Mountain spotted fever cases R is equal to 0.82. Here, again, we have correlation, but do these things have anything in common?
They're both in hot weather months, basically, like over the summer.
Exactly. And that is what we call a lurking variable. Write that down because lurking variable could be on a test or a standardized test. What is a lurking variable? And a lurking variable is something, it's kind of like glue that binds two things together in reference to what? Correlation. Are you going to catch Rocky Mountain spotted fever in the middle of January?
No.
Not unless you live in frickin', South America, somewhere that's warm. And are you going to drown in the middle of December? No. And if you do, I don't know what's going to keep you, the hypothermia or the drown. I don't know what's going to kill you first. But I ain't going swimming in December unless it's in a dang old indoor heated pool. So your lurking variable is hot weather months, which is usually June, July, and August. And that's where we talk about correlation. Now let's see what the book talks about. And let's see if I matched up with anything. Observational and experiment. Researchers, okay, apply a treatment. Could you say that's interjecting? Yes. You have put yourself into an observational study. When you put yourself into an observational study, the observational study is turned into an experiment. And that's two good test questions right there. I think I have a question on the test about that. I'm not gonna test you on those. Treatment group, they receive a treatment. Control group does not. Okay, I do want you to write down placebo. Can somebody tell me a placebo? What is a placebo?
It's when the test subject thinks that they're getting the treatment group.
That's called the placebo effect. Yes. And a placebo, just write down sugar pill. It's a pill with no what? Medicinal value. A pill made out of sugar. And I have a ex-mother-in-law that if you gave her a sugar pill and told her it was a miracle drug for 5 illnesses, the next day she would be playing tennis. Okay? Because a lot of stuff is in some people's heads. You know what I'm saying? And sometimes you can get people to believe that they are healed or believe that they are doing something just by taking a pill. So I want you to write that down. You don't have to write down word for word. A placebo is a non-medicinal treatment. And I'm going to put, I would say, put sugar pill in parentheses because that's usually the most used is a sugar pill. Placebo effect. The test subject believes they feel better because of the sugar pill. That's called the placebo effect. Or the subject has lost weight because of the sugar pill, when actually they were more self-conscious about what they were eating while they were taking the sugar pill. So they didn't eat the Big Mac, they ate the piece of fish. They didn't eat the French fries, they ate the salad, because being on the sugar pill, they put their mindset into better eating. Y'all are learning so much. Some of y'all might already know this. And it says right here, the placebo effect can be very surprisingly powerful. in some studies, up to 75% receiving a placebo actually improved. The mind is very controlling. If you don't know, wait till you have in-laws. You'll find out. Bad Hubert. I'm not doing blind and double blind. You can read over that if you want to. Retrospective. What does the word retro mean? That's a word that's been used the last 20 years. What does retro mean?
The past.
The
The past, going back in time. Using data from 1957 to 2020, I can predict what's going to happen in 2021. That's a retrospective analysis. Going back in time, pulling drunk driving records from the highway department for the last 10 years. That's retrospective. Cross-sectional is usually me going to the highway department right now and saying how many drunk driving deaths were reported in the last 6 weeks. And yes, you could argue that that is retrospective, but it's like modern day retrospective. Retrospective is when you actually go back in time and you pull stuff up to modern times. And cross-sectional is when you actually pull in modern times. I don't even know if they're going to test you on cross-sectional. They do in Math 120. Survey and opinion polls. Opinion polls, are they good for probability and statistics?
No.
Hail to the no. Why? Starts with an S. They are blank. Starts with an S. Subjective. Okay? They're subjective. So when you do a survey, when you write a survey for a, for a project, you avoid, how do you feel? Questions, because they're subjective. You want to keep your data concrete. Yes, no, true, false. You
Yes.
do not want something, how do you feel? You want to stay away from those. Did you say something, Justin?
I was just agreeing with you.
Oh, okay. You could actually, oh gosh, I'm not even going to talk about November, but anyway, we're not even going there. All right, because there's so much that could be talked about in a probabilities and statistics course about November, but we're going to stay away from that because of the buttercups and snowflakes, and we're not going there. Margin of error. We're going to talk about margin of error in chapter 9. Margin of error should be down to 0. The closer it is to 0, the better. You do not want a margin of error on a poll of 8%. You want a margin of error on a poll around 3%. Okay, Ms. Gill, what time does our class end? I want to make sure I stay on time. Is it over at 11 or 11 or 10:05? What does it say on your schedule?
Yeah, I think it's 10. I have it on my board that it's 10.
Okay, all right. Well, we'll go ahead and stop there. If y'all could write in your notes that we're stopping at margin of error, and that is still 5A. Let's see how many pages we got left in 5A. That's it. So I want you to write down confidence interval. Write down confidence interval, and the confidence interval is 1 margin of error to the right and 1 margin of error to the left. And we're not going to talk about that in chapter 9. Chapter 9 is Math 120. Okay, so the sample statistic is right here. If the margin of error is 3 points, 3%, you're going to add 0.03 this way, and you're going to subtract 0.03 this way. So a confidence interval is 1 margin of error to the right and 1 margin of error to the left. You add on the right, you subtract on the left. And I'll give you a couple of examples of that as we go into the homework and people send questions. Here's one right here. An electionees is 52%. So that's 0.52. I'm going to show you this and then I'm going to shut up. Okay. And what kind of margin of error? 3%. So that would be 0.53. And then to the right, 3% would be 0.56. And 3 to the left would be 0.50. Because you add 0.03 this way and you subtract 0.03 this way. That's called a confidence interval. So the confidence interval is from 0.5 to 0.56. That's called a confidence interval. Okay, and I'm going to shut down the presentation. And I'm going to close this down. I've already taken the roll. I've already sent that for Mr. Brown. And has anybody got any questions for me on anything? You are responsible right now